Welcome to The Explainer. I'm absolutely thrilled to be here with you today because we're taking on a massive, almost impossible challenge. We're going to condense 5 billion years of geological and biological history into a single, focused explainer. Drawing directly from the incredible Naked Science documentary, we're going to see how our home, planet Earth, is the spectacular result of a mind-blowing sequence of catastrophes and coincidences.
So, here's our flight itinerary for this time travel journey. We're covering forging a fiery planet, water, oxygen, and ice, the first footsteps on land, dinosaurs and mass extinctions, and finally, the rise of humanity. As you'll see, a brilliant pattern emerges here. Nearly every global disaster actually paved the way for the next massive leap in evolution. Let's dive right in.
Part 1. Forging a Fiery Planet, the Violent Birth of Earth.
Okay, I want you to imagine transporting yourself 4.5 billion years into the past. You're standing in a toxic, choking ocean of lava. It's intense, and there's this continuous, violent, cosmic bombardment happening at a mind-boggling speed, 15 kilometers per second. To put that into perspective, that is 20 times faster than a bullet fired from a gun. And it's the exact speed at which a rogue, Mars-sized planet was hurtling straight towards the newborn Earth.
So what happens next? Well, the aftermath of that insane impact was actually the birth of our moon. First, that Mars-sized planet smashes into Earth, literally turning both of them to liquid. Second, trillions of tons of debris just blast out into space. Third, gravity works its magic, turning that rubble into a red-hot ring. And finally, a 3,500-kilometer wide ball forms, sitting just 22,500 kilometers away. But here's the hidden, unimaginable consequence of this whole impact. It set Earth spinning so fast that an entire day lasted only 6 hours. Crazy, right?
Moving on to Section 2. Water, Oxygen, and Ice. The Chemical Soup.
So, how exactly did a fiery ball of magma get its oceans? Well, 3.9 billion years ago, relentless meteorites bombarded the Earth. But these meteorites actually delivered tiny droplets of water that eventually formed massive pools. But how do we get air? Enter the stromalite. A stromalite is basically a mountain of living bacteria that uses sunlight to transform carbon dioxide and water into glucose. These bacterial colonies are absolute heroes. They literally made the very first sugar, the exact same stuff you put in your morning coffee, and their byproduct was oxygen. This oxygen slowly filled the oceans and made complex life possible. But this oxygen-rich environment eventually hit a huge hurdle. Look at the stark contrast here between pre-freeze Earth and snowball Earth. In the pre-freeze era, we're talking about balmy 30 degrees Celsius temperatures. But then, a shifting supercontinent and extreme volcanic activity created these massive acid rainstorms, and that acid rain absorbed vital carbon dioxide right out of the atmosphere. The result? Snowball Earth. Temperatures plummeted to minus 15 degrees Celsius, and a 3-kilometer thick ice sheet entombed the entire planet for 15 million years. It was literally a giant snowball.
So how in the world does a completely frozen planet thaw out? Well, volcanoes break the ice. Eruptions that were trapped under all that thick ice couldn't have their gases absorbed by the smothered rocks anymore. So billions of tons of CO2 just filled the atmosphere, creating a massive warming greenhouse blanket that finally melted the frozen planet. And here's the amazing payoff. As that ice melted, chemical reactions released huge amounts of oxygen. This explosive oxygen spike kick-started complex ocean life, evolving single-celled bacteria into armored monsters and trilobites practically overnight. It was a total game changer.
All right, Section 3. The first footsteps on land. Escaping the ocean.
Okay, so about 460 million years ago, life was absolutely booming in the ocean. But the land? It was a barren wasteland blasted by deadly solar radiation. So how on earth did life survive to conquer solid ground? The answer is the ozone layer. It's essentially a gas blanket formed when oceanic oxygen met the sun's radiation, creating a shield that absorbed those lethal rays. Once this atmospheric shield thickened up, strange walking fish like the Tiktaalik literally used their fins as legs to pull themselves right out of the water.
And plant life had to adapt to dry land as well. Check out the incredible evolutionary difference here between spores and seeds. Spores are these single-celled particles that need plenty of standing water just to survive and grow. But seeds, man, seeds are a biological masterclass. They carry their own onboard food and water supply, which allows them to survive for months or even years, completely independent of a pond or an ocean. This evolutionary brilliance allowed vast towering forests to stretch far inland.
Now, all those inland forests pumped out insane amounts of oxygen, which led to the downright terrifying Age of Giant Bugs. Seriously, an oxygen-rich atmosphere allows respiratory systems to be way more efficient, leading to massive body growth. We're talking Meganeura, dragonflies the size of eagles, millipedes measuring 2 meters long, scorpions the size of actual wolves. If you hate household bugs, you would absolutely not want to time travel to this era. But here's a totally fascinating fact for you. The massive amounts of dead plant matter from this exact era decayed, got compressed under immense pressure, and actually became the vast seams of coal that we burn to power our modern world today.
Which brings us to Section 4, Dinosaurs and Mass Extinctions, Catastrophe and Opportunity.
Life was absolutely thriving until about 250 million years ago, when massive fissure eruptions in the Siberian plains turned a lush paradise into a lifeless hell of ash. The result was the Permian extinction. Look at this, 95% of all life was wiped out. Only 5% survived. Volcanic heat warmed the oceans, which melted frozen methane gas, and methane is a greenhouse gas 20 times deadlier than carbon dioxide. It baked the planet to 40 degrees Celsius, effectively resetting the entire evolutionary clock.
But, life always finds a way. That surviving 5% paved the way for the era of dinosaurs. About 200 million years ago, the Pangaea supercontinent dominates. Then, 190 million years ago, it breaks apart, and the Atlantic Ocean forms. And here's a fun fact. The dead ocean plankton that fell to the floor of this newly formed Atlantic Ocean eventually became the oil and plastics we use everywhere today. Crazy, right? Anyway, the dinosaurs rule supreme for 165 million years, adapting to everything this restless planet throws at them, right up until 65 million years ago, when an asteroid heads straight for the Gulf of Mexico.
And I really want you to consider the sheer unfathomable size of this thing, 10 kilometers across. We're talking about an asteroid larger than Mount Everest, striking the planet with the energy of millions of nuclear weapons. It instantly heated the Earth's surface to a blistering 275 degrees Celsius. The blast, the global tsunamis, and the ensuing ash-darkened skies wiped the evolutionary slate clean once again.
This specific moment highlights the core theme of our explainer today. The dinosaurs' 165 million year reign is over. But their demise is an opportunity for another species, mammals. Our tiny subterranean mammal ancestors survived the fire and the ash precisely because they lived underground, and they ate absolutely anything. It just goes to show, one species' absolute apocalypse is another species' grand beginning.
And now, Section 5, The Rise of Humanity, the Final Act. Well, at least so far.
Out of the ashes of the dinosaurs, mammals evolved rapidly, eventually leading to our early primate ancestors. In fact, scientists discovered a primitive 47-million-year-old primate fossil that links ancient evolution directly to us. But here's the ultimate mystery I really want you to ponder. Why did our ape ancestors stop dragging their knuckles, stand up, and start walking on 2 feet? It's literally the defining physical trait of the human race. But what exactly forced it to happen?
Well, the answer is an unbelievable geological coincidence. It was a literal push for bipedalism. Step 1. Africa's tectonic plates buckle, creating a massive mountain wall along the east coast. Step 2. These new mountains act as a physical barrier, blocking moisture from the Indian Ocean, which turns these lush rainforests into dry, arid savanna. Step 3. With the dense trees gone and replaced by tall grass, apes are basically forced to stand up and walk on 2 feet just to see over the grass and search further afield for food. The random buckling of the Earth's crust directly caused our ancestors to stand tall. Talk about a coincidence.
Once we were walking, we started moving, embarking on our final migrations. 70,000 years ago, falling sea levels create a narrow land bridge right out of Africa. Then, 20,000 years ago, an ice age forms 2.5-kilometer thick ice sheets, lowering sea levels globally once more. And this massive freeze reveals a land bridge connecting Siberia directly to Alaska. Humans walked across this icy bridge to colonize America, the last great continent. So a shifting global climate and receding ice sheets literally built the bridges that allowed humans to populate the globe. From a toxic lava ball to a frozen snowball, from giant bugs to devastating asteroids, we are the spectacular result of a random, beautiful chain of catastrophes and coincidences. But look at this final question. What terrors and wonders lie ahead in the next 4.5 billion years? We're really only at the midpoint of Earth's incredible story. The next chapter of our restless, creative planet is still completely unwritten. Thank you so much for joining me on this explainer. Keep asking questions, keep looking at the ground beneath your feet, and never stop learning.